Okay, welcome to another Oxford MAT video. I'm having fun with these questions, so I'm decided to just keep doing more of them. And I believe I'm on the wrong slide, so if we go a couple over, this is our question. We've already done that question from the first slide. So this question says a cubic has the equation y equals x cubed plus ax squared plus bx plus c, and has the turning points at 1, 2, and 3d. For some value of d, what is the value of d? And then it gives you minus 4, 2, minus 4, minus 2, 0, 2, and 4. So let's get on with the question. And the first thing that we can do is use this thing here, this 0.12, and we know if it's a turning point, it's somewhere on the line. So we can plug these two values in and form an equation of some kind. So y equals 2. X equals 1, so it's 1 equals 2 equals 1 plus A plus B plus C. So then we can say that A plus B plus C equals 1, and that's our first equation. Next thing we can do is we can plug in 3D. So y is D. X is 3, so 3 cubed is 27, plus x squared, 9a plus 3b plus c. So now we have two equations, two nice equations, which we can refer back to when we know more things. The other clue is the fact that it says turning points. So what is the how do we find a turning point? Well, we differentiate our equation and we equate the new equation to 0. So dy over dx equals x cubed differentiated is 3x squared. Ax squared differentiated will become 2ax. And then we will just have b. The x disappears and we're just left with b. And we know that the turning points, this must equal 0. Because a turning point is when there is no gradient. So we can plug in our 1 and 2. And at this point we're only really interested in the 1 because we don't have a y, we only have things in terms of x. So we have 3 plus 2a plus b. So we can say that 2a plus b equals minus 3. And then we can use our 3. So we can say that 27 plus 6a plus b equals 0. We can say that 6a plus b equals minus 27. At this point we can just solve. We can solve simultaneously we can solve simultaneous equations, and this gives, if we subtract one from the other, so if we take the 6a, we subtract 2a plus b equals minus 3, we get 4a equals minus 24, a equals minus 6. And then we can just plug in that minus 6, minus 12, plus b equals minus 3, b equals 9. So now we have values for a and b, and we can just go back and plug these values in and solve for c, then solve for d. So we have 9 minus 6 plus c equals 1, 3 plus c equals 1, c equals minus 2. And we can just go to this one here, this d equation. D equals 27 plus 9, lots of minus 6, plus 3, lots of 9, plus c. Now this becomes 54, this becomes 27, that becomes minus 54. And if you notice clearly here, 27 plus 27 minus 54 cancels, so that just becomes 0. So d actually just equals c, which equals minus 2. So d equals minus 2. And where is minus 2? Minus 2 is here. So the value of d is minus 2, and that's this question done. It looks quite scary on the surface, but actually, when you get into it, it's not too bad. Thank you for watching, and hopefully I'll see you in the next video.